Hello, my name is Ada. This is the second video of week 3. The last video I talked about techniques for discrete space location problems. In this one I will mention continuous space and a structured overview of classical methods for determining optimal facility location in these spaces. That covers median, contour line, gravity, and V-scales methods. There's 4 methods. There is median method, contour line, gravity, and V-scales. I will firstly mention the median method. This method is designed for single facility location problems, and it uses Manhattan distance. It has Manhattan distance. The separability of the rectilinear objective is the key point in this method. The optimal x and y coordinates can be determined independently by finding the weighted median along each axis. As I mentioned, we first sort by x and then find the optimal x, and then do the same for y. Let's talk about the steps of median method. The first step is to sorting existing facilities by their x coordinates in a non-decreasing order. After that, we find the weighted median x. And for that, we first find the cumulative weight, and where cumulative weight first equals or exceeds half the total weight, it will be our optimal x. And after finding the optimal x, we now do the same for y coordinate. We sort the facilities by their y coordinates, and again in non-decreasing order, and then do the same tests for half the total weights for y, and the first point that it equals or exceeds the total weight is our optimal y. Here are key properties for median method. We use it because it has axis independence, and it's to determine x and y separately and independently is easy for us to find optimal location for a facility, and this method guarantees optimality. That no other coordinate pair yields a lower total weighted rectilinear distance, and so the weighted median is the global optimum. And alignment with existing facilities is another point. The optimal coordinates will coincide with those of one or two. So here is an example of this method. We are given different facilities and their x and y points of coordinates and their weights. Firstly, we calculate the total weight. Here we sum the 4, 3, and 5. That equals to 12. This is our total weight. We have to find the half of this weight, which is 6. And the rule is that the coordinate where cumulative weight first reaches 6 is the weighted median, and it will give us the optimal location. So here you can see in the table that we sorted the facilities locations by their x coordinates in an ascending order. And after that, we start to sum up the weights from the beginning. When x is 2, the cumulative weight is 4, which is less than 6. So we continue. When x is 5, the cumulative weight becomes 7, which is greater than or equal to half of the total weight. So x equal to 5 is our optimal x value for our location. After finding x, as I mentioned, we now do the same for y coordinates. We sorted the locations and we start to sum up the weights. When y is equal to 1, the cumulative weight is 3, which is smaller than 6. And when y is equal to 3, the cumulative weight is 7. Again, we reached and exceed the point 6. So y is equal to 3 is our optimal y value. We select y as 3. So here we have our final answer as the optimal location is 5 and 3 for x and y. In this method, again, the key idea is to solve each axis separately and take the weighted median on that axis. Here we have a linear cost model. The rectilinear single-faceted problem can be formulated as this linear model, and it's introduced a composite weight parameter for each existing facility. Here you can see the parameters. Fi is traffic flow between the new facility and existing facility in this example. And Ci is unit transportation cost to facility I. Xi and Yi are the coordinates of existing facility I. And we have our decision variables as x and y. Here you can see that the product of Ci and Fi is shown as composite weights. And the total distribution cost can be seen as this formula. In this formula, the x and y values that you can see are the optimal coordinates for the facility that we want to open. From cost model to weighted median, for this transition, we have to firstly define weights with the formula that I mentioned. We have the product of Ci and Fi for each existing facility, which is Vi, that is composite weight. And then we separate exits and minimize them independently. After that, we apply the median steps, which we saw in the example, to find the optimal x and y. After these steps, we have our optimal location and as the coordinates of optimal x and y. Here you can see the comparison of these different methods. I mentioned median, and in the other videos we will mention the others. Here you can see their distance metric can differ to another, and their approach is the main difference among them.